Hello everyone, welcome to 10.6 Graph Quadratic Functions using Properties. Here we look at three objectives: to recognize the graph of a quadratic function, find the axis of symmetry and vertex of a parabola, and lastly to solve maximum and minimum applications. All right, quick recap. When we say quadratic equations, we have some telling signs. This is a polynomial of degree 3. I've mentioned this before, it's just a quick recap. Of degree 2, and the shape is a parabola. So if the polynomial has degree 2, you can automatically expect your graph to either look like this or inverted, okay? And that's what we see here in this box, parabola orientation. So if your equation, the quadratic equation, is y equals ax squared plus bx plus c, okay? You can expect your parabola to open up or down. Well, we're saying, how do we know if it's going to open up or down? Another cool trick is A tells you how it opens up or down. This A is very, very important. If A is positive, then you know that the parabola opens upward. If A is negative, you know that the parabola opens downward, right? And so without even graphing, without even looking at the graph, you just look at the equation and you can come up with these very determined ideas of how the parabola will open. So let's come over here and do graphing. So here it says graph y equals x squared minus 1. Always scan your equation, right? If it's a linear equation, then the degree is 1. And so we will just use 3 points to graph. Actually, we need 2 points, but third point would serve as a test. But here you scan your equation. This is a polynomial of degree 2. And that implies that the graph will automatically be a parabola. What more, you can actually look at the A value. In this case, we don't have a B, right? This equation doesn't have a B. It only has an A and a C. So this implies that when A is actually 1 here, right? A is right there. So A is 1, which is positive, which implies the parabola is going to open upwards. So before we begin graphing, we have all these clues stacked up. And so when we do the graphing, we can kind of use it to cross-check if we did it right. Now remember, this is a parabola, it's a curve, it's not a line. If it is a curve, then you want to see the turn of the curve, and so just 2 points or 3 points won't be sufficient, right? You may just be only looking at one half of it or one side of the parabola. So in order to kind of spread out the turn of the curve, we recommend that you use at least 5 points, okay? So for the sake of our working here, let's make it -2, -1, 0, 1, 2, okay? If you want more points, again, you could make it -3. So bring it from the negative and from the positive so that we could keep the spread better. So I just added the -3 and 3 in case you were going for more points. And as always, you will adapt to your given problem as to how you want the selection of x values to be. These are your choices. What I gave you, the first 5, are just the traditional choices. And so we tend to go for them as our usual pick. All right, so now you have, I'm going to do the calculations over here. So y equals, the first one is -2. So that's x squared minus 1. I'm plugging it in the equation so that I could find the corresponding y. So -2 the whole squared is 4, because -2 times -2 is +4. 4 minus 1, which is 3. I enter that value here. And then let's plug in for -1, which is 1. Minus 1 is 0. Let's plug in for x as 0. So 0 squared minus 1 is -1. 1 minus 1, which is 0. I'll plug in 2. 4 minus 1, which is 3. Okay, and I could go on for the other 2, but I'm just going to restrict myself to these 5. Okay, and remove these 2. Now look at your y values. Do you see some kind of symmetry there? Right? You see that the numbers are the same on either sides of -1, right? There's 0 and 0, 3 and 3. So there is something that's going on there. And that symmetry is a good thing because your parabola is always symmetric. The left half of the parabola mirrors the right half of the parabola and vice versa. So because of this symmetry, you will see that your numbers also reflect that symmetry. Okay. Now, if you don't see the symmetry, sometimes it could be because of our number choices. That kind of tells you that you should spread your numbers even more, okay, on both sides. So let's go ahead and graph these points. Okay. Now, this is a graph grid with the scale already marked in it. So let's go ahead and do -2, 3. -2, 3 is right here. Oops. Too strong. Label it. -1, 0. That's on the x-axis. 0, -1. 1, 0. And 2, 3. You can already see that the dots begin to trace, the symmetry of the parabola. And because this is a parabola, it's not a line. You can't use a ruler on this one. You just have to draw the curve by hand. This side didn't come well. It's very hard to draw without touching the screen. Okay, that's better. Okay, that's a parabola that's U-shaped. And the name of this parabola is y equals x squared minus 1. We've spoken about the parts of the graph in the beginning of this course. So please make sure that your scale is marked. In this case, the scale was already marked in blue for us. If not, you'll have to do the scale and get your points and draw your graph. Now, what you see here is the parabola has some distinct features. Okay, the most striking feature is that this 0, -1, the bottommost point of your graph, that is the point where you see the symmetry on either sides, right? That point is the lowest point. We call that point as the vertex. So call this as the vertex. As you can see, vertex is a point. So the point is 0, -1. So if you can find that point, you know that, if the parabola is opening upwards, above that point, you'll find symmetric points on either sides. And if it is a parabola that opens downwards, then you know that that's the point below which you'll find the symmetry. So the vertex is definitely a defining characteristic of a parabola. And we also notice that if you can see me drawing this dashed line, it's kind of hard because it's coinciding with the y-axis. So what I did was I did draw the dashed line through the vertex. That dashed line is called the axis of symmetry, because that is the axis about which you can see the symmetric features of the parabola. Now, if you were to fold this on a piece of paper along the axis of symmetry, you'll see that the green arms of your parabola will coincide with each other, right? That's the meaning of symmetry. And that's what we have. So the symmetry actually the line of symmetry or axis of symmetry passes through the vertex. Okay, so let's write a quick note here. Vertex is the lowest point if it is like this, right? Or highest point if it opens down like this of the parabola, right? The vertex. And then the axis of symmetry is the line that, or I should say vertical line, let's make it vertical line there. I'm just putting it in my own words so that it's easy for us to understand. I do have a definition coming up. This is the vertical line that passes through the vertex. Now, very clearly, the axis of symmetry helps you to see the symmetry in the parabola. And that's what's coming up here. Okay. So here the definition, or rather the formula for axis of symmetry and vertex of a parabola is given to us. It's really, really neat. Now, if you want to know, because we know that once we get the vertex and using A, we can determine if it's opening up or down, right? If A is positive, it opens up, negative, it opens down. So just these two details will help us to actually build the parabola, because we know that the symmetry and how it opens will help us to finish the graphing even more quickly. But to find the vertex, we have to use the table if we were to graph it, right? But this formula helps us to get that vertex without ever having to graph. We're getting this all algebraically, and that's why, again, it's powerful, okay? So vertex is a point, x comma y, let's say, right? Let me write the x properly. So vertex is a point, x comma y, and we're trying to explain what that x stands for. So x is, or rather I can just box it from here. X is negative b over 2a, and that goes into your y to get your y. So let me write it out here, okay? So vertex is a point where x is negative b over 2a, because you get the a, b, c from the equation. And this is function of negative b over 2a. What that means is you're trying to plug in this answer into the equation to get the y coordinate. Okay. You'll understand this when we look at the problem. Okay. All right. For the parabola, find the axis of symmetry and the vertex. So now we have the graph here, the grid, but we're not going to use the grid to do the graphing in order to find the vertex. We're going to use the vertex formula to do this. Okay. So there are two things here. So the vertex, let's just write that here. The vertex formula says, to find the point, you need to first find the x value, which is negative b over 2a. Take that x value, plug it in this equation, wherever you see x, and that will give you the y coordinate for the vertex. Okay? So I'll just point out this. This is the x coordinate, and this is the y coordinate. Okay, so negative b over 2a. So let's figure out what is a, b, and c from here. Let me quickly write it by the side here. A is 3, b is negative 6, and c is 2. Well, we don't need c in this formula, so it's basically between a and b. All right, so negative b, put the shells, please, over 2a. And then we plug in for b as negative 6. You notice that there is double negative there. A is 3. Okay. So that's going to be positive 6 over 2 times 3 is also 6. That gives you 1. So x coordinate is 1. And so to find the y coordinate, just like we've done before, you take this x value, plug it in your equation. So y is 3 times x squared minus 6x plus 2 is the equation. And in the equation, you're going to plug in 1 that you just got from x coordinate. Okay, 3 times 1 squared is 1, minus 6 plus 2. So 3 minus 6 plus 2. 3 minus 6 is negative 3. Negative 3 plus 2 is negative 1. Okay, we just got our vertex. So let's collect the x coordinate, which is 1, and the y coordinate is negative 1. We found the vertex just like that using algebra without ever having to do the graphing. Okay? So the question was to find the axis of symmetry and the vertex. So we found the vertex. Actually, we answered part B first. Okay, that's fine. A is the axis of symmetry. Remember, this axis of symmetry is a vertical line that passes through the vertex, right? It's a vertical line. So if you can visualize this on the graph, right? Let me show it to you here. 1 comma negative 1 happens in the fourth quadrant. 1 comma negative 1. And your parabola, from looking at A is positive. So it opens upwards, okay? So I'm just going to sketch this because I really don't know other points. So say I'm going to sketch this. It's going to look symmetric like this, right? That is assured. It's going to open up. It's going to look symmetric like this. I really don't know if it's going to open wider like this or it's going to open narrower. We don't know because we need more points for that. But remember this question is only asking us to find the vertex. So let me just remove these things, okay? Just to give you an idea there. All right, so you have the parabola there around it, and you're drawing the line of symmetry, or the axis of symmetry. You can clearly see that your axis of symmetry must be a vertical line that passes through the vertex, right? A vertical line is always of the form x equals a number, okay? What number is it? If you recall that lesson, x equals a number is usually the number through which the vertical line passes. The vertical line passes through 1, so the equation is x equals 1, okay? So that's the equation that we need to give, because you can't just say it's a vertical line passing through the vertex. When we are speaking in algebra, we have to be very specific and give the equation. Now, this vertical line is not part of the graph, so we need to kind of what do I say, make a dashed line. In graphing, when you do dashed line, it tells us that it's not part of the graph, it's just for reference. In this case, the reference is to see the vertical, is to use this vertical line as axis of symmetry. So coming down here, the axis of symmetry is x equals 1, which is the line, okay? What's really cool is your axis of symmetry is always going to be x equals the x coordinate from your vertex, okay? Because that's the only way you can draw a vertical line, isn't it? And it's always going to pass through the x coordinate of the vertex. So for generality, say x equals the x coordinate of the vertex. So in this case, finding your x coordinate of the vertex first helps us to actually answer the axis of symmetry. But even otherwise, if you get the vertex, you can also visualize it like the way I showed you to understand how the vertical line would pass through the x coordinate. Okay, now let's move to applications, solving maximum minimum applications. So if you again recall, we were just talking about how the lowest point of the graph is the vertex when a parabola opens upwards, and the highest point of the parabola is the vertex when your parabola opens downwards. Now, the lowest and the highest point, when I say that, we would rather use the language as minimum and maximum. So the vertex becomes the minimum point for a parabola that's open upwards, and the vertex becomes the maximum point when a parabola opens downwards. And as you can see, the maximum or the minimum is attained, right? That's the point. So that's the x coordinate, but that's the y coordinate, right? And here, that's the x and that's the y, okay? So y is technically pointing to the height, how high, what is the maximum, and x tells us where that maximum occurs, okay? So I'll say y tells us what is the maximum or minimum, and x tells us where it occurs. So I could just say this is all related to the vertex x comma y, whatever that point is, this is what happens. So in a word problem, you may be asked to find out the maximum or the minimum, in which case, if that's what they're asking you to do, they're basically asking you to find y. If they're asking you where it occurs, then they're asking you to find x. So we need to answer the question very clearly and carefully. Okay? So let's take a look at this question. Find the maximum or minimum value of the quadratic equation, and that's given to us. Now, we don't have to graph this. Okay, that's the whole point. The whole point is to be able to do this algebraically and verify it graphically. So for that, we'll just do a quick sketch. Again, I need to know where the vertex will be, and we're going to find that. But just by looking at the A, B, and C from here, let's do that. A is -4, B is 16, and C is -11. A is negative, which implies the parabola is going to open downwards, right? And so, again, I'm going to sketch this here, but if it works differently, I will change it. I know it's going to open downwards, just randomly drawing it somewhere here. That will be my vertex. Look at the figure. The vertex is the maximum point or the minimum point. Clearly, the vertex is the maximum point, okay? So we are actually trying to find the maximum point. That's the vertex. But then they use the language maximum value, okay? When they say maximum value, then they are actually talking about the y coordinate, okay, for the vertex. So let's go ahead and find the vertex for this one. So vertex is -b/2a, and that number must be plugged in your equation to get the y coordinate. So then let me say x coordinate is -b/2a, shells for that. And I will draw b and a from the list here. So b is 16, that goes up there. A is a -4. Okay. So that's -16 over -4. 2 times 4 is 8. Negative over negative is positive. 16 over 8 is 2. So your x coordinate is 2. Okay. Y coordinate of the vertex is this 2 plugged in the equation. So y is -4 x squared plus 16x minus 11, shells for the x's, and then let's plug in 2 in all those places. Again, don't race ahead, do it systematically because we use PEMDAS in all of these. So 2 squared, you have to do the parentheses and then the exponent first. So 2 squared is 4 plus 16 times 2 minus 11. Now we can multiply them. Negative 4 times 4 is -16, plus 16 times 2 is 32, minus 11. So -16 plus 32 is plus 16. 16 minus 11 is 5. 16 minus 11 is 5. So the vertex is 2, 5, right? That's the x coordinate and that's the y coordinate. Well, honestly, I did not see the graph before, but it seems like I got it somewhat in the right spot. Right? If this is 2 and this is 5, then my vertex is kind of located mysteriously very correctly. Okay. So let's come back and respond to this question and say, and we established that this is going to be the maximum point. So I'll say the graph reaches the maximum value at 5. Oh, I'm sorry, reaches the maximum value 5 at x equals 2. Okay. So this is your y value, y coordinate of the vertex, and this is the x coordinate, which tells you where it occurs. That's why I say at. So that's the x coordinate of the vertex. As always, you want to look at the question and see what they want and respond appropriately. Let's take a look at this word problem. An arrow is shot vertically upward from a platform 45 feet high at a rate of 168 feet per second. Use the quadratic equation h equals -16t squared plus 168t plus 45 to find out how long it will take the arrow to reach its maximum height, and then find the maximum height. Okay, well, this is more related to physics, but again, if you look at the problem itself, it's really not it seems very practical, right? This is to be expected in real life too. So let's draw the sketch of the grid. Again, we can visualize this when we draw the sketch, but we're not asked to graph this. We're just asked to figure out the maximum height. Okay. Again, because it's a word problem, you really want to do all the steps, right? So the step one is to draw a table or draw a diagram. So we're drawing a graph in this case. Okay, so you know this is your x-axis and this is your y-axis. But if you come back here, let me write the equation here. Negative 16t squared plus 168t plus 45. You see that you don't have an x or a y. Instead, you have two different variables. The two variables are t and h. Okay, so h is written in terms of t. Okay, if h is written in terms of t, what this means is if I plug in values for t, if I plug in for t, I'm going to get corresponding h, right? So that means you now have t comma h, that is your x comma y. Okay, so I'm going to rewrite my x-axis as the t-axis, and I'm going to rewrite my y-axis as the h-axis. So we are so familiar with x and y, we have to now adjust our minds to the t and the h. So let's come back and see what this t represents, because now it's the t-axis and the h-axis, right? So t represents, where are we? The time. This is an arrow that's shot upward from a 45 feet high platform. So let's say 45 feet was up here, right, from the ground. Then your arrow is shot upward, and then it's going to come down and reach the ground, right? Actually, I shouldn't put the arrow because it can't go past the ground. So it reaches the ground. So we're trying to see, let me do a better job of that. So we are trying to figure out what is this maximum height that the arrow reaches, right? So that's the height, maximum height. Okay. And where it occurs is the time t, because that's happening on your t-axis, right? So for this t, what is the corresponding height you get? T comma h. So then I come back here and say, okay, t represents time in seconds. It takes seconds for the arrow to go up and then come back down. And h represents the height. And the height is given to us feet per second, so we know that the height is measured in feet. Okay, so we have a little sketch here, right? And this is step one of your word problem. Step two is to identify what is missing. Okay, it says how long it will take the arrow to reach its maximum height, and find the maximum height. Okay, so let's write that out. How long to reach the maximum height, and the other part was, what is that maximum height? How long and maximum height. Because it talks about how long, I'm going to call this as t, long. How long here means the time, right? So that'd be t seconds. Okay, we don't call the units yet. So I'm just going to assign variables to this. And for the maximum height, I'm going to call it h. That's what we already saw. So it makes it all linked together. This is basically my step three, right? Step three in the word problem list says to assign variables to what's missing in step two. Then step four is to build a relationship, translate this problem into math. Well, this is pretty much easy at this point because we know that we're trying to find the vertex, right? I wrote that there. So I'll write it again here. Vertex is this t, and h. H is the maximum height here, and t is the time it takes to reach that maximum height. Okay, so let me interpret that. This means time to reach maximum height, comma, the maximum height. You with me on this? You can look at the picture, right? The vertex is the maximum height. That's the highest point. the arrow is going to touch before it heads down. So there is a time it takes to reach that point, and we're trying to figure out what is that height. All right, let's come back here. So your x coordinate of the vertex is negative b over 2a. Okay. And if you go back to the equation, let me collect a, b, and c. Let's keep it closer here. A is negative 16. That again makes sense, right? Your a is negative. This implies your parabola opens only downwards, which is what is happening. Also, practically speaking, yes, you're shooting an arrow upward. It's going to go up and then come down. As you imagine it, as you trace your finger, thinking about it, you can already see that you're tracing a parabola that opens downwards. Okay, and B is 168, C is 45. Okay, so negative B over 2A. B is 168, and A is negative 16. Okay. So these are bigger numbers, so you want to use your calculator. That is negative 168 over negative 32, right? Negative 2 times negative 16. And you know that the two negatives will make a positive. So that will come out as 5.25. Well, we always write them as fractions. Okay, remember this is a word problem. So it is fine to keep this. Moreover, this is a terminating decimal number. So we are fine with this. 168 over 32 is 5.25. It's the negatives become positive. And then let's use that to find the y coordinate. Y coordinate, go back to the equation. It's not y equals something in x, but it's actually h equals something in t, right? So let's write that out. H equals negative. Let me quickly insert something here. Okay, the x coordinate is basically the t you're trying to find. All right, negative 16 t squared plus 168 t plus 45. That's the equation. And we're going to plug in 5.25 in all these places. Okay. So I do need my calculator here. You can pause the video at this point and maybe do the calculation yourself. That will be really helpful in you knowing, how to work this out. All right, so you can see that I did the calculation here. And because it's a terminating decimal number, it actually rounds up nicely. You didn't have to do any rounding, really. It rounded itself nicely because of the 0.25 and all that. Okay, so we got our x and rather a t and our h. So you can say the vertex is t comma h, which is 5.25 comma 486. Okay. Now that is just a math calculation. Okay. Now we come to interpreting it. Oh, by the way, to kind of check this, we can do the check. I'll just show you the check. We'll do the check by plugging in this t comma h into our given equation. Both sides must be the same, right? So maybe 4, and this is step 5 where you do the actual calculation. Step 5 of your word problem steps. Step 6 is to check. And for that, we're taking the equation. H is negative 16t squared plus 168t plus 45. We got the h to be 486. That's the maximum point that we chose. There are many points that will be on the parabola, right? Infinitely many points. But this was just one of the points. And let's plug in this, what was it, 5.25 that we just found. It seems like a little redundant because we're basically doing the same thing, but this is just checking your calculation the second time. Okay, upon doing the calculation, you get 486 equals 486. That verifies that your calculation was right, meaning your numbers were right. So step 7, the last step of your word problem, is to interpret your answer. So we'll say, coming again here to step 5. Remember, T represents seconds and H represents the height in feet. So keep that in mind when you come to interpret. We'll say the arrow reaches its maximum height of 486 feet in 5.25 seconds. Or you could say at 5 point, I'd say at, because it's instantaneous, right? The arrow is moving at every second. So we can say it reaches this particular height exactly at 5.25 seconds. Right after that, it begins its descent. So we got the maximum height. So this is your y, or rather in this case, your h. And this is your x, or in this case, t. I hope that helps you to understand and analyze these problems for their practical value, and also use math concepts of finding vertex in order to obtain the maximum or the minimum height and where it occurs. All right, I hope to see you in the next chapter. With this, we end chapter 10. See you in the next video.